Okay, so this section's all on the geometric mean. Okay, on the geometric mean, and for any, we're going to go through geometric mean for just numbers, and then we're going to go for the geometric mean in a triangle. Okay, for any two positive numbers A and B, so it has to be positive. For any two positive numbers A and B, the geometric mean is the positive number X where the proportion A is to X. Now they might write it with a colon. A is to X equals X to B. They might write it like that. Most of us are used to writing it in this form. A is to X as X is to B. Okay, and when you cross multiply, okay, you're going to end up with X squared. Because when we cross, we're going to multiply these two, okay, and we're going to multiply these two. Okay, so X squared equals AB. So that means if you take the square root of both sides, the geometric mean equals the square root of their product, AB. Okay? So this is basically how you find the geometric mean between two numbers. If I give you two numbers and I say I want the geometric mean, you multiply them together and you take the square root. Don't make it any harder than that. Okay? Okay. And in words, it basically says the geometric mean between two numbers, and where you said they both had to be positive, is the positive square root of their product. So this is the main formula for the geometric mean between two numbers. You multiply them together, take the square root. Okay? So, example. Find the geometric mean between two and 50. Okay? You can set it up in a proportion, but you don't have to. If I set this up in a proportion, it'd be 2 is to X as X is to 50. And then I'd end up with X squared equals 2 times 50. And then I'd take the square root of both of them. Okay? So X equals the square root of 100. So X equals 10. You do not have to go through all of this. You can go right to, you can just say the geometric mean X is the square root of their product. And then go right to your answer. Now, some of these won't come out evenly, so you have to pay attention to the directions. Do they want you to round it to the nearest tenth, to the nearest hundredth? Okay, so you can work it either way. Okay. Okay. So if I said find just abbreviate it, find the geometric mean between 25 and 7 to the nearest hundredth. So if I said on this one I want to figure the geometric mean is the square root of 25 times 7. Okay, so on the calculator, check the mode. For right now, we're going to leave it in floating for a minute. Okay, and go 25 times 7. Now, I still want to see your work, even though you're doing it on the calculator. So I still want to say, write out, that'd be the square root of 175. Okay, and now do square root. It's right above the x squared. So you're going to do second function square root. Now, don't type in 175. Okay, get used to using the answer. So right above the negative sign, use second function answer. That's going to fill this 175 down in here. I want you to get used to that, because if down the road in trig and calc, if we're working with long numbers, we don't want to have to type it in. You just want to use second function answer. So use second function answer. It's right above the negative sign. Okay, and then press enter. Okay. And here you see all the decimals. Yep, so it'd be 13.228. Now, if this is 5 or greater, you're going to round that up. So x is 13.23. Okay? The idea? Second function. And then the answer is right above the negative sign. Anything that's above the keys. Okay? So what we did here was we put in, we did the 25 times 7 and then equals. Okay, and then we did the second function, square root, and then I did second function answer. Okay. Now, if you were doing like several problems, like I said, if you're doing several problems and they're all to the nearest hundredth, okay, now go back and change your mode. Go to mode. And go from floating to 2 decimal places. Okay, and then do second function quit. That takes you back. Okay, now just press enter. Whoops, sorry. I need to do it again. Do second function square root of 175. Okay, now see, it rounds it for you. Okay, that's what, and everything's going to stay on the calculator in 2 decimal places. If I shut this off and I put it back up on the wall, it's set to 2 decimal places. Somebody from trig comes in here, if they're not paying attention, and if I say what's the sine of 40 degrees and they just put 2 decimals, they're going to get it wrong. Okay, so you want to pay attention to how many decimal places your calculator's set for. Okay, let's keep going. So basically, geometric mean is the square root of their product. Okay. For right now, that's fine. Yep. Didn't change. Hang on. Okay. Let's go through. The author does a theorem. Theorem 8.1 says if the altitude. Okay, now we're talking about triangles. If the altitude is drawn from the vertex of a right triangle, and I'll show you a picture in a minute. Oh, sorry, hang on. I'm saying the wrong word here. If the altitude is drawn from the vertex of a right angle of a right triangle. You can just use a symbol for triangle. To its hypotenuse. If the altitude is drawn from the vertex of a right angle of a right triangle to its hypotenuse, then the two triangles formed are similar Okay, and remember the symbol for similar is this. Okay, if it's got the two lines underneath it, it's congruent. So these are similar to the given triangle and to each other. Okay, so picture-wise, make this a right angle up here. Okay, there's a right triangle. Label this X, label the right angle Y, label this Z. Okay, if we draw an altitude is drawn from the vertex of the right angle, and remember, an altitude has to be a right angle down there too. It doesn't necessarily split this in half. No. Okay. Okay, then the two triangles formed are similar to the given triangle. So label this point W. Okay, so the similar triangles are triangle X, Y, Z. That was the original. Is similar, and it has to be in the right order, to triangle X, W, Y, because you got to pay attention where's the right angle. Okay, and triangle Y, W, Z, in that order. Triangle X, Y, Z is similar to triangle X, W, Y, and it's similar to triangle W or Y, W, Z. Okay. Okay, then the author goes through theorem 8.2. And it's called the geometric mean. The geometric mean, and in parentheses put altitude theorem. Okay, and it says in this YW, the altitude, YW is the geometric mean. You can abbreviate it. The geometric mean of XW and ZW. YW is the geometric mean of XW and ZW. Okay, another way to say that in words, the altitude is the geometric mean. You can abbreviate it. The altitude is the geometric mean between the two segments The altitude is the geometric mean between the two segments of the hypotenuse. Okay, and the proportion would be xw is to yw as yw is to zw. Okay? Okay, and another way to say that, look, if you cross multiplied, you're going to get yw squared, right? Equals the square root of the xw times the zw. So if you look at the picture, the yw squared, this altitude is the square root of this times this, right? xw times zw, and the square root of the whole thing. So you need to take square root of this side too. You've got to take square root of both parts. Okay. Okay. Now let's look at an example. Okay. Find the measure of the altitude. Find the measure of the altitude to the nearest tenth. Okay, and draw a right triangle picture-wise. Label this as A, this is B, the right angle C. Okay, the altitude goes from this vertex to the hypotenuse. That makes this a right angle. Okay, they give you this, label this point is D. From A to D is 2. From D to B is 6. And they want you to figure X. Okay, basically the altitude is the geometric mean between the two parts of the hypotenuse. So it's just like we did at the beginning. Take the product of those two numbers and take the square root. It's that simple. Okay, so what's the square root of 12 to the nearest tenth? What would it be if you rounded it to the nearest tenth? To the nearest tenth? What was it, 3.46, and now round it to the nearest tenth? So final answer 3.5, right? Okay. Nearest tenth, they want you to take it to one decimal. You got to look at the hundredths place. If this is 5 or greater, you round it up. Okay. So the altitude is the geometric mean between the two parts of the hypotenuse. Okay, last theorem. Theorem 8.3. It's called the geometric mean, and in parentheses put leg theorem. Okay, and it says if the altitude is drawn, if the altitude spell it right, is drawn from a vertex of a right angle of a right triangle. Just use the symbol for triangle. If the altitude is drawn from a vertex of a right angle of a right triangle to its hypotenuse, then the measure of a leg of a triangle, just use the symbol for triangle, is the geometric mean, you can abbreviate that, between the measures of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Okay, if the altitude is drawn from a vertex of a right angle, of a right triangle, to its hypotenuse, then the measure of a leg of a triangle, okay, the leg is the geometric mean between the measures of the hypotenuse and the segment. Okay, so example, or picture, let's do a picture first. Make this a right triangle. Okay. Drop a perpendicular down. This is our altitudes. That makes that a right. Okay. Label this leg as B. Label this leg as A. Okay. From here to here, label that X. From here to here, label that y. And this whole hypotenuse of the big triangle, label that c. Okay? Okay, B is the geometric mean, okay, between the whole thing and the leg that touches B. So B, the leg, is the geometric mean between the whole thing, so that's C, and the leg that touches B, the part of the hypotenuse that touches B. Okay? So B is the square root of C times X. Okay, A would be the square root of the whole thing, C times Y. Okay? Okay, so now let's look at two examples. Find C and D in triangle JKL to the nearest 10th. Okay. Draw a picture. Make this your right angle. I didn't draw that very good. Label this triangle J. This is J. The right angle is K. This is L. Okay, drop the perpendicular, the altitude down. Okay, label this as M. Okay, label this as D. This is 5. Oops, I didn't label that. I didn't draw that very good. This is 5. JM is 5. ML is C. Okay, and KM is 10. Okay, we have to find D and C. Okay, let's find C first. Okay, 10, the altitude. 10 is equal to the square root. The altitude is the geometric mean between these two parts. So 5 times C. How do I get rid of that radical? Square both sides. So you square both sides. Maybe I'll do that on the next step. So, okay, so you'd have 10 equals 5C square root. So you're going to square this side and square this side. So you'd get 100 equals, and all that's going to do when you square that is get rid of the radical. So you'd have 5C. Divide by 5 on both sides and C equals. Okay, be careful now. .0. Yep, because they want it to the nearest 10th. Okay, I just counted some wrong yesterday on trig because they didn't follow that direction. So, mean old lady Elliot. Okay, now we have C. So we know what C is. C is 20. Okay, what's D? D is the geometric mean. The leg is the geometric mean between the whole thing. So what's the whole thing? So it'd be 25 is the whole hypotenuse and the part of the hypotenuse that's adjacent to it. So 5. Okay? So D equals the square root of 125 to the nearest 10th. What would it be? Round it to the nearest 10th. Yep, because it ends up to be this. It's 5 or greater, so final answer 11.2. Okay. Okay, last example. I want to make sure you know what you're doing. Okay. Okay. Find X and Y to the nearest 10th. When you figure out on this section, all you're doing is multiplying and taking the square root. It makes it much easier. Okay, draw a picture. Make this your right angle. Drop the altitude, goes down, and makes that a right. Okay. Label this as A. This is B. The right angle is C. Okay, this one is 8. I'll label this letter as this is D. AD or BD is 8. AD is 3. This is X. And this is Y. Okay, what's X equal? Quick, what's X? Right, square root of 8 times 3. So square root of 24 to the nearest 10th, what is it? Square root of 24 to the nearest 10th. 4.9. Good. Okay, for Y. Square root of the whole thing times the one adjacent to it. Square root of 33 to the nearest 10th. What is 5.7? Okay? Okay? Okay, that should be enough to get you started.